Hi, Assalamualaikum and a very good day to the panels. I am Haji Razali Hassan and Dr. Freddawati Rashiddy Wong. So today, I'm Muhammad Faris Rosni will present my FYP topic, which is water filter using rice husk, sample characteristic and jig development for flow test. First of all, I would like to express my gratitude to those who helped me throughout this semester, which is the staff from RS Advanced Ceramic Tech, Ms. Nur Azad and Ms. Farah, and of course the technician from the UI10 lab, Mr. Nur Azman Benodin. Alright, this is the content for the project or the research. The first one is the introduction, then problem statement, research question, objectives, scope of the project or the research, the methodology, the results, the significance of works, conclusion, and also lastly, recommendation. This is the introduction. Malaysia is a country that rich with a biomass resources which have variety of benefits or advantages. One of the biomass product is the rice husk, or in the short form, RH. RH is actually the cover that protect the white rice grain, and the weight of RH is actually about 20% of the rice weight, and it has the content of 50% of cellulose, 25 to 30% of lignin, 15 to 20% of silica, and 10 to 50% of moisture. Well, based on the statistic that I provided, Malaysia achieved a rice production of 1.88 million metric tons of rice husk in 2019. Well, this actually creates a problem such as the disposal method. Farmers usually burn the paddy residue, which leads to air pollution. So the only way to solve this issue by utilize the RH to its full potential. So this project will utilize the RH and change the RH into water filter materials. The RH will be collected from Sekinchan and Pasir Putih from the Kelantan. For every research and project, there must be a problem. So the problem statements for my project is the feasibility of fabricating RHA-based filters and its characteristic. The next one is the performance of the RHA-based filters itself. After reviewing from the past research done by other researchers, there's several questions that become concerns to me in this project. The first one is how actually to fabricate the filter from rice husk ash, how to measure the filter performance, and also what type of analysis that's suitable to measure the filter performance in this project. Okay, let's move on to the next slide, which is the objective of the project or the research. The first one is to fabricate the RHA-based filters and determine its characteristic and or properties. And the second one is to design simple water filter system in order to measure the filter performance in this project. Okay, this is the scope of the project. First, we need to fabricate the RHA-based filters through the powder methodology process and determine its characteristic from mechanical strength perspective. And another one is design simple 3 stages water filter system and also measure the filter performance from permeability perspective. After the scope, there is methodology step. There are 5 steps taken, which is first, I need to design 3 stages water filter system, and then I need to manufacture the RHA-based filters, or we can call it samples. Then prepare the sub-samples from the samples and conduct the pressure, permeability and 3-point bend test, and also observe and analyze the results that we gain in this project. As I have mentioned before, powder methodology approach was used to craft the filter using RH. The first process involved the mixings of additive and RHA. But first, I would like to apologize as I cannot reveal what type of additive that we use in this project because it is due to the privacy of company information. And then there's a milling process by using the ball milling, and followed with the addition of binder and turn the mixture into slurry. After that, the slurry was dried partially until it turned to powder with the color of grey to black, and it is stored tightly in a container. This is very important step because it is used to prevent the powder from losing its moisture. Next, the powder was put into a designated mold for pressing process and followed with the sintering process to ensure the product have a good strength. Alright, this is the details of the methodology steps, which is the subsamples preparation. In the first picture on your left, it shows the samples that prepared for 3-point bend test, and each material, which is RHA from Sekinchan, RHA from Pasir Putih, and ceramic, the commercial filter, will have 3 samples each with the dimension of 7 x 10 x 55mm cube. And the second picture on the right is the samples that prepared for the permeability test, and each material have 1 sample with the dimension of 7 x 10 x 10mm cube. The tools or equipment that were used to prepare the samples are hacksaw and and sandpaper with the grade of 80. The next slide is on the water filter system design that was designed by using drawing software CATIA V5. The design has the aim or the purpose of simplifying the process to determine what components that are needed to buy and to complete the system. The components are the water tank, which is to store the water, the control valve to control the flow of the water or the pressure, and the booster pump to boost the pressure, of course. And next, the filter to filter the water, and the pressure gauge to indicate the pressure level, and the water tube to channel the water. This slide shows the setup apparatus for pressure test, and the design that was used for this test is actually the design that I have mentioned to you or shown you before in the previous slide. And the pressure of water is varied from 15, 10, 25 and 30 psi, and the volume of water that flowed into the filter casing was measured and recorded. The first run used all 3 stages with ceramic filters, then followed by RHA filters from Sekinchan and Pasir Putih. The figure on the left is the setup apparatus of the IWAL permeability test. The components that used are funnel, the samples, the sealant, and the container with scale. First, the samples was put into the funnel holes, and the gap will be filled with the sealant. Then 100 ml of water was poured and let it flow. The time taken for the water to flow completely was recorded, and the trial for each samples are 3 times. The experiment was continued then with different samples materials. And the right figure is the universal testing machine that was used for 3-point bend test. The jigs alignment was first checked at the first place to ensure the load act on the samples directly. Both of the specimens end were marked first to prevent misalignment, and the test rate was set to 0.5 mm per minute with bending span of 38 mm, and the maximum stress of each samples were calculated and recorded. Okay, this is the results for the project. The first are the filters that were produced, and the left one is the RHA Pasir Putih, and the right one is the RHA Sekinchan filters. And from observation, both of the filters have a rougher surface compared to the ceramic filter, but RHA Sekinchan seems like has smoother surface than RHA Pasir Putih filters. And RHA Pasir Putih has the color of grey, light grey, and RHA Sekinchan has the white color surface. This is the result for the pressure test. Overall, we can see that when the pressure increased, the volume of water that flowed into the filter casing also increased. For RHA Pasir Putih, we can see there's a bit irregularities on the second stage of filters. It seems that it has more capacity, it has more volume of water that flows in compared to RHA Sekinchan stage 2 and ceramic stage 2. This may be due to a small crack on the filter surface of RHA Pasir Putih on the second stage or stage 2. And as you can see, ceramic achieve the lowest volume of water in the filter casing. This is maybe due to the porosity size that are different. Okay, this is the permeability test results. Based on the graph, ceramic took an average of 328 minutes to filter the 100 milliliter of water completely. Well, the time recorded is about 4 times longer compared to the time taken by RHA samples from Sekinchan and Pasir Putih. Meanwhile, RHA Pasir Putih sample took the fastest time, which is about 61 minutes in average to filter water. These results actually can be affected by the factor of the porosity size, and through calculation, the Pasir Putih can be considered the most permeable among the 3 sample material, with the value of permeability 0.0273 milliliter per second. Here is the result for 3-point bend test. This test managed to measure the flexural strength and the maximum stress for each sample materials. For ceramic, all 3 samples exceed 0.06 kN of force. Compared to other materials, ceramic gained the smoothest line graph. RHA Sekinchan and Pasir Putih have unstable line graph. This is due to the system instability and the material brittleness. For RHA Sekinchan, samples 1 and 2 managed to exceed 0.009 kN of force, but sample 3 fractured earlier than expected at 0.002 kN. For RHA Pasir Putih, the samples exceed 0.004 kN, with sample 3 as the highest, which is 0.008 kN. This is the graph that will be used to determine or identify correlation between material strength and density. Well, from the graph, it indicates that ceramic has the lowest average density but the highest average maximum stress. For RHA Pasir Putih sample, it has the greatest density among all of them but the lowest average maximum stress. Usually, the denser the material, the greater the strength of the material. But this result shows an opposite trend. These 3 figures shows the surface of the sample material's cross-section after the 3-point bend test. And from the rough observation, ceramic sample has the smallest pore size and the most complex connectivity of pores. RHA Pasir Putih seems like has larger pore size than RHA Sekinchan. Well, maybe the pore size actually affect the strength of the materials. Apart from that, this is the significance of works for this research or for this project. First, it will boost the development of green technology in Malaysia or the world. Second, it will help to introduce an economical and reliable new product. And the last one is, it will help to encourage more research to be conducted on natural waste or renewable energy in the future. These are the conclusions that can be made from the result that was gained in this research or this project. The first one is the RHA base filter was successfully manufactured without problem, and the next one is pressure actually affect the water volume in filter casing or the flow of the water. The third one is RHA base filters is actually more permeable than the commercial one, which is made from ceramic. And the fourth one is ceramic filter has higher strength and it is 8.6 times stronger compared to the RHA base filters. And the last one is sample strength actually not affected by the density, by surface roughness and porosity size distribution. For the purpose of improvement in the future work, these are the list of recommendations that I list out. The first one is we should review back on the formula to manufacture the RHA base filters. And the second one is we should use a better or advanced method on the analysis type and apparatus, since in this project I use a lot of DIY method or traditional method or conventional method to analyze the permeability of the samples and materials. That's all for me. Thank you so much for spending time with me. Assalamualaikum warahmatullahi wabarakatuh.